just give. So when you log on to this, when you check for interface type, the first is tab, second option is HA, and virtual wire, and then layer 2 and layer 3. So tab means, like, if you this interface you want to use as a kind of, I can say, like a span port, because the tab port is something which will just get a copy of the actual traffic which we want to send to this interface. So in that case, it can be a tap interface, like kind of, you can say, a passive interface. Some firewalls and some OEMs call it passive interface. So that's one option. The second is, if I want to use it as for HA purpose, point-to-point connectivity to the other firewall for redundancy, then I can choose this option of HA, because once I choose HA, then a lot of other options don't exist, because this would just be used for heartbeat scenario. So in this case, as you can see in tab, you get an option for configuring security zones for the interface, but in HA, we don't have any. We don't have to assign any security zones, so that option goes away as soon as I select HA. And the third option I have is virtual wire. So again, virtual wire is kind of if I'm putting firewall, or I want to use this interface of the firewall as a virtual, offline basically. So that in case my firewall fails, or this interface fails, I don't want to block any traffic. So that's kind of a virtual wire, that the traffic will go through the firewall, but it will be not inline. So its failure does not make any difference. It's just kind of monitoring and generating logs for me, but not blocking anything, because it's not in the path of the traffic. So these are very rarely used options. But yeah, layer 2 and layer 3 is what we generally use, and layer 3 being used the most. Again, so layer 2, just like in case it's connected to a layer 2 switch, and we want to do MAC based forwardings on this interface, then I'll go with the layer 2 option. And if you see in the layer 2 option, I get an option of VLAN as well, because layer 2 would work on VLAN basis, like which VLAN it's a part of. And we don't have an option to configure IP address in this case. Uh, and the rest, same, like we can still define a security zone. We can define all these basic things like link speed, duplex, etc. And the last option, which is the most commonly used, is layer 3 mode. Now, if you see the options that we have for layer 3, it's a maximum, because this is where we need to configure few things which are required for it to be functioning in layer 3 mode. So we have an option to define IP address. It can be IPv4, IPv6. It can An IP can further be a static IP, which is what we mostly define on firewalls. But in case there is a firewall, which is just used for VPN, site-to-site VPN purpose, right? So in that case, what happens is, in some scenarios, customers do not have a static IP from the ISP. The public IP that they assign on the external interface, that's not static. So and it keeps on changing. Uh, so in that scenario, we do not have we cannot choose static option. So we have to choose PPOE, or we can choose DHCP client. So because in that case, generally the IP is assigned by DHCP, and it changes after some period of time. So we have.
Now I will just say quick thing. My laptop automatically got started rebooting. Just give me a couple minutes.
Okay.
Yeah, just give me a couple more minutes. It's logging back.
Sure, no, take your time.
I'm not sure what happened automatically. It's error. I think that Windows 7 error. You're logging in, Mavi. Just 2 more minutes. It says loading, but I'm not getting anything. So
you're not able to see the screen?
no, it just says loading. So I'm not sure what's happening. But let me open in a different browser.
So if you think it's a Zoom issue, I can cancel it and send a new invite.
Yeah. Now, okay. It should be in. Yeah, I'm in.
We can start.
Yes, one second. Yeah, it's connecting. Okay. Yeah, I can see you.
Okay.
Okay.
Fine. So we were just configuring this interface
Right.
1/1.
Mm-hmm.
So I'll just, I was just about to assign the IP address. So
Okay.
just assign this, okay. I'll first just assign this profile and then So delete this. Yeah. Okay, so yeah, so I had to configure an IP address on this interface. So I'll just add the IP address of the interface, which is 192.168.1.1, I would say. And once I configure this address, then I will just save it, and I'll just make it static because I don't have to use that, and I'm not using any DHCP. The other things that I can look into is link speed, link duplex. I'll leave it as default because auto is what all the other devices work generally nowadays, so no need to touch that. Then the other info is like if I want to adjust the TCP maximum segment size, I can do that for a particular interface over here. So default value for IPv4 is 40, and for IPv6 is 60. So what we can do is, if we think that the maximum segment size of the packets that we are going to receive on this interface is going to be higher, then we can on the safe side we can change it, and there's no harm in making it higher. But if it is lower, then it might drop some packets. The other thing is, like, if you expect kind of jumbo frames, so then you can customize the maximum transmission unit and queue size over here. Let's say if I expect that, yeah, I would be getting jumbo frames, which is like 1500 size. So I can change that, and I can look for ARP entries on this interface. So any ARP entries that's learned for a connected router or or a layer 3 switch, that will show up here. So that's important. I mean, that helps at times when we're troubleshooting that some connectivity issue. I'll come to the interface and see if the interface is learning the ARP of the directly connected device. Alternatively, if we want to like kind of just test it, we can set a, I mean, like, we can define a static ARP as well. So I can just give an IP address of the router connected or a switch, and the corresponding MAC address of the interface. So we can define static ARP entries at the interface level. Yeah, and if there's any proxy, we can define the proxy settings over here as well. And LLDP, which is like the protocol used for MPLS. So if this firewall is connected to some kind of MPLS router and going to receive some kind of WAN or intranet traffic, then we can enable MPLS. I mean, sorry, LLDP as well over here. But in our case in the lab, that's not the case. So I'll just skip this part. So I'm good with this information, and I have defined the IP address. I have, okay, yeah. So the config part, I have to assign, a virtual router. So basically, a virtual router is nothing but just, yeah, it's just the routing settings basically. So how would I be using this interface for routing purposes? So basically, it's kind of adding a route. So I just add it like, give it a name, like it's going to be my external interface. So I mentioned that name. Now the static routes that I want to use is I don't have a route, so I'll just add a route over here. So I have to give a name like my van route, let's say, okay, and or I'll say it's internet route better, internet route, and the destination. So I can make it as a default route by saying 000, or I can give a static subnet over here. So I'll just make it like 000, and because it's a WAN interface, I want to make it default route. And yeah, so in interface we can define the interface, but I don't want to define this because it's it's my 1.1 interface. I don't want to define any other interface. And yeah, there I give next up IP address would be, like in my case, 192.168.1.1.1.2, right? So this is my connected router interface, and that's all that we require. The other fields are optional, so I can just say okay. So I define a static route that would use this, or I would say a default route that would use this interface, and I just say, and I have other options as well. If you see, while configuring virtual router for the interface, I can define if I want to use this interface to be a part of, or I want to run any routing, dynamic routing protocol like RIP or RIP, OSPF, BGP, multicast. So, I mean, it's completely like a router, right? So it supports all those options for pairing up with the router interface. So we have that choices. So we can just say, okay.
Okay.
Okay, I think I missed the subnet over here. Yeah. So I've done this and now this. So once we, for every interface, we need to define a security zone that it's going to be a part of. So this would ensure, just like if you compare it with ASA, when we can use to configure ASA, we used to define like external or outside, inside, and or LAN or DMZ. Now, what was the purpose of assigning those, or defining those zones? Was like when a traffic flows. So when we assign that zone, the firewall used to assign a particular security level, or there was a numeric identifier for each zone, and like yeah, DMZ was considered more like the,
Untrusted zone.
yeah, and LAN was the most trusted, and outside the least trusted. So when traffic goes from LAN to outside, you need to enable some policy. Uh, I mean, it can go free, sorry. And when it comes from outside to inside, you need to enable policy because it travels from low to high trust. So all those functionalities, because of all those reasons, the same here, we have to define a security zone or for an interface. So decides that, okay, this traffic is going from a high secure zone to a low. We need a, we don't need a policy. It's going from low secure to high. We need a policy, something like that. So we define that over here. And so I have created a zone here by the name of DMZ. So I've chosen that DMZ. If I want to create a new zone, I can create it in this and add that as well. So I think this part is done. Some configuration I'm missing, because once you have all the configuration done, then this OK button highlights. So I think I missed something in the advanced section, I believe, which is mandatory. I did configure. I want to untag it. I tried to define this. Okay, delete this. Yeah. Okay. So that was the problem. Okay. All right. So I have my first interface configured now, and I can see here the values which I assigned have been popped up. So that's fine. And if I want to give a comment, I can give this comment. This is just like a description basically, and this started since Checkpoint used to use comment for every configuration. So this is this comes from there. Anyways, so yeah. Now once so this way I can configure the other interfaces. So in my lab, I'll just be using two interfaces. So I'll configure the other interface. I mean, I'll have to configure one more. I'll configure it later. I just want to show you one, and then I'll configure the other myself. So now the other things which I can configure over here is a VLAN. So why would you need a VLAN? It's just that because in case you have a switch, which is a L3 switch, which is connected to the firewall. Now, in that case, we need to define the VLAN and assign it to the interface so that when my traffic goes out of that interface, it has the correct VLAN tag so that, the switch can also identify it in the same VLAN. So that is the purpose. But if you have a router on the other side, then the interface that we configured is that settings are sufficient. So, nice one. So then if I have to define a VLAN, I can just configure the VLANs basically. I'll add a VLAN over here. Let's say VLAN name is VLAN DMZ, or I'll give identifier VLAN 10. VLAN interface, I'll give the same. Okay, I don't have a VLAN right now assigned to an interface, so that's why. Okay, so let's do one thing. We'll cancel from here, and it's better we'll create it over here. So the other options here is loopback. If in case we want to do some testing, we can create a loopback interface, or we can create a tunnel interface as well. Now the second option, which we have to configure, is a zone. So I have right now a zone which I use in my interface, the 1.1, but we'll create a new one to see overall configuration options we have for the zone. So I give it a zone zone. Now, for every zone, we have an option to define these settings. So log settings, I can define the same syslog server which I've used for the other zones, or which I've added, or I can create a new syslog server as well. So then I have an option. So we can do both ways. While configuring an interface, we can call or bind the interface to the zone, or we can, while creating a zone, add an interface to it. So I know I'll be using another interface down the line. So I'll just add, interface. Sorry, I'll just add interface Ethernet. Uh, 1/2. No, just give me a minute. Let me check my interface. Yeah, it's either 1/2. Right. I don't know why it's not taking here. Okay, I'll assign it from the interface. I think this license might be not knowing this. Okay. So yeah, now interface, I can assign directly from the interface section as well. Then zone protection profile. This is the most important section while configuring a zone. So I have one profile which I created, but if we want to see exactly what all options we have, and of course we can use a different zone protection, or we should use a different protection profile for each interface or for each zone. So I give it a name for this protection profile that I'm created. Zone profile. Now here, what I have option is like flood protection. Do I want this profile to do these kind of flood protections, which I'm expecting on this zone or interface? So if I want to do TCP SYN flood protection, then what is the rate of traffic that I'm expecting? Or what are my thresholds? So these are the default thresholds, but if I expect like maybe more than this, I mean, this is something which is very low for my environment, then I'll of course consider increasing these so that I don't have genuine traffic dropped in false positives and so unnecessary rate blockings. So I can increase this. So the first is alarm rate. So if it reaches like 100K, then the fire on this particular zone or interface, then the firewall will start generating alarm. And activate means that is the place where the firewall starts or gets activated to do the rate limiting or protection. And the maximum connections that it can allow at a given point of time is this number. So ideally, activate is should be higher than alarm zone, because if you get an alarm at
Activate in the case, how many connections can it handle, right? How many TCP connections can be activated at per second? Activate connections per second. That is like how many TCP sessions can be activated or can be initiated, correct?
It's the other way around. So it's like, so how many connections can be handled is this number maximum.
Okay.
This maximum is what what is the number of connections it will handle. Activate basically means like okay, so if you have set up, so there are three things. If there's a volumetric attack of SYN flood, or so how does the SYN flood attack, that a user or a client will send a SYN, and the firewall will send a SYN ACK, but the ACK would never come. So what will this do is this will keep on that connection open at the firewall as an idle connection. And the idea is that if these kind of connections keep on increasing, the firewall will not be able to close these connections, and that would consume the resources. And at a given point of time, the firewall CPU and memory may spike. So in order to control this, we can rate. We generally the only option or the best option is to rate limit. Now, rate limit is in rate limiting. What we do, we have a number defined here, which says that okay, if my firewall gets up to these kind of SYN half open connections, then I will generate a log entry or generate an alarm. That is one thing. That is just a passive thing, nothing to do with blocking. Now, if I get like 200K connections, then I will activate my protection mechanism. Okay. So protection mechanism means, start dropping the older open, half open connections or something like that based on the signatures and the configuration we have done. But the maximum I'm going to tolerate is 400K. If it goes beyond that, then I'll start dropping everything.
Okay.
So this is where I start my mitigation, and this is where, so at this point of time when I start my mitigation, I'm still considerable that I'll only drop the half open ones. But if this number is reached, then anything after this, the same goes with UDP. We have three options. If we want to enable Icmp protection, again similar. Icmp will not enable V6. We don't have a V6 environment, and any other IP thresholds, right? So generally, these kind of thresholds you can also configure on if you have a DDoS appliance, because DDoS appliance mostly sits before the firewall for the traffic coming from the internet. So ideally, this kind of rate limiting is very well supported by DDoS appliance, and it should be done there. But in case there's no DDoS appliance, then we can use the firewall for the same. So if you see here, random early drop and SYN cookies. So these are the two ways that it can protect against SYN attacks. So SYN cookies means like if there are SYN cookies and you want protection against that. Now, these are the basically primarily the characteristics of a DDoS appliance actually. Then other protections that we can enable is reconnaissance protection. So TCP port scan. Now, there are tools on the internet available like Nmap and other similar tools which can do the port scan for and find out and give you what all ports are available on what all websites or what all IP addresses, right? How that works is that, if your firewall is there and of course you might have enabled port 80 and on the firewall. Now in case you have enabled that, on the public IP address of the firewall, which is reachable over the internet, then this, Nmap and other scanning tools will be able
Mm-hmm.
to scan and find out that this IP address has these ports enabled, and then it becomes very easy for an attacker to do kind of telnet and SSH related attacks. So if I want that my firewall should not be listed in those kind of scans, then I'll enable this, protection against TCP port scan, UDP port scan, host sweep. So this is for that purpose, and I can configure a alert to happen, or I can configure block of the IP as well. So the IP who tries to do a port scan to my firewall interface on a particular port, I'll block that IP, and I'll block that IP source for some particular time. Okay, so this is what I can do. Right. So the other things that I can have is like enable ACLs. I can define a new ACL over here, or if I have a defined ACL, I can add it over here, and I can. So basically, these ACLs that I'm defining here. These are for uh, access to this zone. Um, so, and I can include or exclude some addresses which I want to be part of this. So if I want to allow an address, I can just add it over here. If I want to remove, I can just remove it from here. Or I can just have a ACL defined and then add it over here. This is a better option. So this is the one I've created. Right now, whatever I'm doing configuration, this configuration is not actually saved into my device. So what I'll have
You
to
need to
do is,
commit it, right?
yeah, right. But in most of the other appliances, you find that in GUI it saves by default. In CLI, you have to just save it yourself. Uh, oh, okay. I haven't added the external interface. So, yeah. Did we add the VLAN? So I'll add the VLAN. Um, I don't know what this is now. If I create a VLAN over here, I can create a VLAN. I can go to the interface and I can assign the VLAN over here. So I'll choose a layer 2 and now I'll be able to assign that VLAN over here. And if I want to have a zone, I can define a zone, maybe now what zone I can have a maybe an IPLS zone where I'm defining this VLAN. Yeah. So in this, we have seen already the last profile that we created about the flood protection and reconnaissance. Now what we can do is we can check a couple of other settings that we have. Packet-based attack protection. So if there's a request coming from a spoofed IP address, I can check for that. I can do strict IP address check, which means like, if that IP address has been ever blocked by my firewall, any request coming from that IP address would be considered as an attack. Any fragmented traffic that's coming. So now if there's a, because why do people send fragmented traffic? The reason is if they send a fragmented traffic, then at the firewall or the receiving device and it has to combine those fragments to make it a complete packet. So that takes some kind of effort at the receiving end. So that kind of attack again is targeted to make you know to consume the resources of the device actually. So that's where again, but if I expect I have some applications in my data center which uses jumbo frames, then I mean, I expect to receive some kind of fragmented traffic, because every device in the path would not have supported jumbo frames, and that makes sense. So in that case, I should not check this option, else I might end up dropping genuine traffic. Sorry. The other options for IP option drop is strict source routing, loose source routing, record route, etc. So malform. We can do more on the TCP drop side, which is like where most of the attacks would happen. TCP SYN with data, TCP SYN ACK with data. So these are the two options which mean that just the SYN came, or just the SYN ACK happened, but no ACK happened. Split handshake, we can enable. Split handshake means like you got a SYN ACK from a device or an IP address, but the ACK came from a different IP address. So what attacker did is like he is randomly changing the IP address, so just to confuse the other side, and send SYN ACK and then ACK with a different IP. So that's a split handshake. So yeah, that can again be blocked using this TCP drop option. So if there's a non-SYN TCP you want to reject, and asymmetric path, so probably the path that's for the request and response, that's different. So in that case again, there might be a chance that it's trying to confuse the firewall. So we have an option to reject that. Stripped TCP options. So when the response goes from the firewall, for any response from the firewall or the response that it's relaying from a server, do you want to remove the TCP timestamp? If yes, then we can check this. So the idea is why we want to remove the TCP timestamp is because using the TCP timestamp, the attacker can malform the packets and resend the older packets and something like that. So generally, it's recommended to remove the TCP timestamp for security of the applications.
Okay.
And multipath TCP only happens in case of again MPLS. So not generally used apart from that on internet. Again, ICMP, we drop most of the ICMP stuff. We don't want the ping to work, So all of these ICMPs ideally should be dropped. IPv6, these are the default checks. But since we are not using, I mean, if one is using IPv6, then these checks should be enabled. But otherwise, these should not be enabled. So, I mean, if you look at these checks, they are pretty much IPv6 protocol related header checks actually on the left side. On the right side, it's basically the feature wise what all IPv6 supports. For example, Anycast. So Anycast is a feature which is there in IPv6, which ensures that if you have an IP address, okay, let's say you have a couple of data centers in different locations. Now, generally what happens, or what we understand and observe, is that the public IP address that you will have in data center in US will not be the same as the public IP address that you will have in the data center in Europe. Now, so in case to use that effectively, what people used to do was like they used to have two DNS entries, and the public US and Europe was like keep on something like manipulating or load balancing between those two IP address. Now, to solve that problem, Anycast was introduced. So what Anycast does, actually this feature is something, first of all, your ISP has to support. If your internet service provider does not support this, then there's no point of, I mean, no firewall or router itself can do this. So what this feature does is that now your US IP address, US data center public IP address even if your US data center goes down, the same IP address would be reachable through the Europe data center. You do not need to have another public IP address for Europe at that time. So anycast means any IP address anywhere. That's the meaning. So
Mm.
now what sometimes this, so there's a issue with that as well, that like even if in case if it might not be a genuine traffic as well, that your IP address is reachable from America, but someone sitting in the Europe has spoofed that IP address, to send a request to that IP address in Europe at the same time. So idea of any cast is that that IP address would get the request in any one data center at a given point of time. But attackers try to send the request to both the data centers at a given point of time. And that's where enabling this check would ensure that this device
This
would,
is a threat.
yeah, the genuine traffic when this IP address is active on this data center or this firewall. That's the whole idea. Then we have Icmpv6 drops, so that's pretty much like Icmp drops, and the protocol protection. So protocol protection is like where we can add the protocol by names which we want to protect. So let's say I want to protect. So I can just say Mac. I want to protect. I want to protect. Let's say. What other to? I can say like MPLS. I can add MPLS. So it has to be a well-known protocol, and the firewall has signatures, so it'll use those signatures. And there has to be some hex value for that, which we have to define. I'm not defining right hex value. Actually, this we can get from the protocol RFC or details like that. So these are the protocols which I have excluded from being checked. I can include the protocols also. I just want to check. I just want in my include list, I'll not have these. I'll have, let's say, what are the protocol I want to check for attacks is, let's say,
HTTP or HTTPS?
yeah, we can do that. I was just thinking of any layer 2 protocol. Okay. Fine. So, right. So we can do that. Yeah. HTTPS, I can put, but HTTPS makes sense only if I am offloading. I mean, I'm putting the certificates and offloading here. Otherwise, HTTPS protection would not be complete. So I did that, and now my zone, so this is my another protection profile, which I assign on interface 1/3 that goes towards my MPLS. And I made this a layer 2 interface. It's connected to an MPLS switch. And I made this interface a VLAN. I mean, I assigned a VLAN to it. And I don't need to, okay, let me enable LLDP in this case because it's an MPLS interface. So I've done with this interface as well. Okay. So till now, what we have seen is like we have seen three things on the network side: interface, zone, and VLANs. And we also created a, no, we didn't create a virtual route. Okay, we created a virtual router. Sorry, yeah. So we created a virtual router, which is like just like nothing else but a route, actually, static route, and we can have the other protocols that are supported. So as of now, the firewall supports BGP, but there's another variant of BGP, if you know IBGP. So this Palo Alto does not support IBGP; it supports BGP, or you can say eBGP, external BGP.
BGP.
Yeah, it doesn't support IBGP because it's not considered to be a complete router for the LAN, and so yeah, so IBGP is not supported. And the other protocol, like which is proprietary, like the AZURE-VIRTUALIZATION and all that, is not supported. But RIP version 2 is supported. OSPF, you can see OSPF version 3 and
Version 2.
yeah. Yeah.
So I'm just curious, Novel, when we define the virtual router, right? Is it like creating the virtual router? Is it mandatory, or because we define the zones, that is like external interface and internal interface, that is where we create the trusted zones. And in the trusted zones, that is where the virtual router, that is like a sort of a IP address, we are defining it, right? For that particular interface.
Okay, so yeah, there are two different things. So when I define a zone, in the zone, what I can do is I can define the interface that is bind to that zone and a protection profile. These are two primary things that I assign to a zone. Now, let's say in this case, the DMZ zone has to communicate. So a machine in a web server in the DMZ zone, sorry, I clicked. A server in DMZ zone is to be accessed by some people over the MPLS. So what will happen? They'll come to interface 1/3, which is a layer 2 interface, and then they have to go to interface 1. I mean, a server behind interface 1/1. Now, the challenge, I mean, the reason why we are defining virtual router is that how would these guys landing on the MPLS zone or interface 1/3, how would firewall know where it has to send, which behind which interface? So for that, we need to have a route pointing towards 1/1 for the server subnet, which is behind the DMZ. So
Okay.
router is just a route that we are creating on the firewall for routing.
Gotcha.
That's the whole idea. Nothing more than that. I mean, they could have called it a route or something like that to make it look easy, but it's just a route. If you create.
Yeah, so that all the traffic, anything coming from trusted zone to untrusted zone, it has to know where it is going or how it has to point to, right? So we are just binding that layer 2 to a layer 3, if I'm not wrong.
Come again? I couldn't get the first part. What you said?
No, that is like all the traffic. However, the traffic has to be defined. So we are just providing a sort of a static route in the virtual router, right? So any traffic coming from this interface has to be the default route, or the next stop need to be my untrusted zone.
Yeah, that's right. I mean, the route that we are defining under virtual router can be for multiple scenarios. Like one example we took, that coming to MPLS and going to DMC. The other could be like, someone from the LAN wants to reach out to internet. So for that also, I mean, in the router define, just like we define a default gateway basically. So vice versa, we can have route pointing for someone coming from LAN and going to MPLS side. So it's just a static or a dynamic route for communication between the interfaces. So one interface knows, I mean, traffic coming onto one interface, the firewall knows that destination is behind which interface. That's the whole idea.
Okay. Yes. Well, let me share my screen now really quick.
Okay,
I
I'll
just
stop.
want to.
Yeah.
Get online. Let me know if you're able to view my screen.
No, yeah, it's coming up.
Okay. Let me close it.
Yeah, no, I can see it.
Yeah. Okay. So in the network, if you're looking into, so I have two interfaces. One is my untrusted virtual router, and the other is for the trusted. So this is how it is configured. So when I go back to the virtual route, I have two static routes, like total of 11 static routes defined for the trusted, and for the untrusted, I just have two static routes. So that is like, let me click on the. It's taking forever. Okay. I go to the static route. Let me expand this.
Yeah. So if if we look at this, the first one is internal route and the second one is default route.
Right.
And both are on the interface 1/1. So I assume that this interface 1/1, is it the one going toward, I mean, is it the LAN interface or kind of a internal interface?
It
Trust,
should be an internal interface based on the
trusted, right?
config. Just let me
Or
cancel it 1 second.
it's untrust, right?
Right. So
So
interface Ethernet 1/1 is connected to the virtual router untrust VR.
so I think that's the one which goes out through which it goes. That's the external interface which goes out to internet.
Internet, and this is the one which is coming into the trusted. So this is my coming into the trusted internet
Right. So,
Ethernet 1/2.
so the two routes that you showed me for Ethernet 1/1, one was a default route, right?
Right.
The second, yeah. So that means like anyone in your network who wants to go out to internet, he would use this route via and go out via untrust interface. Ethernet 1/1. The first route is kind of a static route for 10.0.0. network. I'm not sure how that network is reachable. Uh, yeah,
So
the
this
first
is
one.
like any internal route. This is like okay. This is for the untrusted. From the untrusted, when it is coming into the trusted, that is all 10 network. It has to go through the trusted network. And if it is a default route, anything which is, so this will be going through the 10.246. 10.246 is nothing. 96.33 is nothing
Next
but
up router.
load balancer IP. And from there, it will be like either going through the Azure MPLS, or I'm not sure how this is set up. But anything which is coming into internal with 10 network, it has to, from the interface 1 dot, the next hop or will be my trusted VR, right?
Yeah.
But anything which is default, this is again 96.33 is the, I think the load balancer or whatever they have configured in the Azure. This is Azure load balancing. So they are just
Yeah.
defining
So
the load balancer IP.
yeah. So what I expect, like this also gets some request, which has. So is there your guys have some kind of VPN or WAN or MPLS?
No, I don't think we don't have any MPLS kind of VPN, nothing. It is just like, let me open the diagram and that would be more easy for us to go over. Just give me 1 minute.
What I'm trying to just understand is like, I understand
Right.
that route makes sense that everything it sends out to the load balancer, link load balancer, I think, and then load balances. But why would it get some request for 10.0.0.8 on that interface? How we get that?
So anything which is like internet to 10 dot, okay. 10 dot is nothing but the default, right? Which is the subnet, the internal subnet for Azure. This is all 10 dot network, which is like
Oh, okay. It's
in
for
Azure we have. It's all in Azure. So in Azure, anything which is 10.246 network. So that is like /8 we are defining it. If I'm not wrong here.
now it makes sense. Okay, so it's Azure. Okay, I was just thinking
Right.
that why you have a private IP on the internet, but yeah, that's like so if it's Azure, that also has to go out via internet only.
Right.
But then this
So that
communication is with Azure, this should be, I mean, some kind of a private network, not like a normal internet.
right, Naval, even that is like a kind of a private network, but we get that one.
That's why I asked, like, it would be some kind of a VPN or something because we are routing with private IP address.
Oh yeah, this is all private IP, so which is coming through the express route. That is like via the MPLS cloud in Azure. From the
That's what.
MPLS cloud, it is coming in. But end of the day, it is coming into this the Microsoft Edge routers. It enters into Azure. So I'm just like curious where does this 10.246.99.33 is, because these are the 4 PALO firewalls which are being clustered. So just give me 1 minute. Let me. Then okay, this is a 24600 subnet. Okay, so I think this particular firewalls, right, which I'm logged into, the PALO firewall, this is
Yeah.
all internal traffic, anything coming from the 10 dot network. So anything 10 dot network which is coming through the express route. And if you're seeing, this is all the express route being coming as the internal route, internal network. So all the 246 is coming via the Verizon MPLS cloud, which is treated as all internal. Gets into this particular firewall.
But this subnet, this IP address 10.246.96.64, where is this destination actually?
This is all the destination is like, if you're seeing it again, it's been like submitted into prod various subnets, I can say.
So this
is all part of Azure.
Yeah, so the VNet peering that you're showing in the below sections like prod, dev, this is all a part of Azure, huh?
Right. This is all part of Azure. So anything here, I'm using it, right? So this is the prod network, dev network. So anything from prod to dev, it goes through VNet pairing. But if it is like a user-defined route, which we are defining, apart from this, if it is anything to go, here you are seeing, right, 100.37, the default route, or the it has to go through 100.39, which is nothing but the virtual IP on the Azure load balancer, which is like clustering these 4 PALO firewalls. So the traffic goes to the web, which is like .39, and 39 is the one which is load balancing all the 4 IPs, 4 PALO firewalls. So traffic can be picked by either one. And these all PALO firewalls are being managed by Panorama.
Yeah. Makes sense. So yeah, now I understand what you're trying to say. So that makes sense because now now if you look at your routes, so on your untrusted interface Ethernet 1/1, you have 2 kinds of route. One is for a normal default route for any outbound access, and the other route is for the destinations which are in Azure, starting with the 10.x network. So for that also it has
Right.
to go out of your network. That's why it's going out of the untrusted interface, right?
Okay.
And
So you mean to say,
can you show me the trust interface routes? The
yeah, 1
11.
second now. Yeah,
Yeah, you had some question over here.
Yeah, this is my untrusted. So anything internal, which is like all the 10 dot network /28, it is coming through the interface, which is untrusted, again pointing through the trusted, and it needs to go to wherever it has to go, right? It is sort of a VNet peering, or if it is a prod QA environment or whatever it is. But anything the default, which is it doesn't have this particular destination, then it has to go through the load balancer, which is like the default route of 96.333 is nothing but the IP, which virtual IP, and it will be like balanced across any of the.
So it'll send to that load balancer, and load balancer will send it out via your internet link. That part is fine, the
Right.
default one. But the first
Yeah.
one is, anyone who has a destination, because I think the pairing that you have done with the Azure is using the trust interface that was showing over there.
Right.
Yeah. It's not in this.
So this is a trusted interface, right? So anything coming in, or apart from this, all zeros, which doesn't have the 10 dot network. So if you're seeing it, this is again all zeros. This is user-defined routing, which we are forcing it to go through the dot 37.
Yeah, that makes sense. So now what happens is that any traffic. Okay, so I just want to scroll a little bit upwards, the green section.
Okay, let me minimize the screen. Is this enough?
Yeah, that's fine. So
Yeah.
now what happens is that any traffic that comes from express route and it has to reach to this 10.x network, which is actually your trust subnet, which you see here 10.46.100.0. Now that will
Oh,
come.
oh, no, no, now one quick thing. So is it like my source is nothing but 10 dot network, right? But my
No,
destination,
no,
it is like I'm using it. Oh, okay.
no. 10.0 is your network. I mean, sorry, destination.
Uh, I thought it's my source which is coming in.
Now, if
Okay.
you look at the route, go back to that route of untrusted one, and
Okay. Oh, yeah, this is the
this
destination.
is the
Okay. Yeah,
destination
I got you.
column. Yeah,
Okay. Destination. Anything default route for the destination, it has to, which is like this is trusted network. So all my default, it has to go through the untrusted
correct.
network. But if it has a specific route, which is like 10 to 46 or these particular subnets, it is
Subnets.
going through the
Correct.
246.100.1.
Yeah, right, right. Because by default, we do routing based on destination. So that's what being done here also. Unless you have a requirement to do source-based PBR, that's a different thing.
Okay, so here my next stop, I'm specifying it to which default network it has to go to, correct?
Yeah, so that means yeah, anyone who comes with comes for a destination 10 for 246.100.64, I'll send that to 10 246.100.1, and I think 100.1 would be a connected device to your firewall interface.
Okay, so but 100.1 is nothing but the load balancer IP, I think, if I'm not wrong, but
Yeah,
I need to double check on how the configuration is. If it is like 100.1, the default is okay.
it doesn't show 100.1 in this
Uh,
diagram.
yeah, because the only thing is these palettes are the virtuals, right? So if you are just binding this paleto to the virtual or the VM interface, and that is where we are defining that particular 100.1.
Yeah, so
If you're
100.1
seeing
be the VIP on the uh,
10 to
I will
4600.32/27 network, that is a slash
2 slash
27. So
27
this
will
is
not have one.
no 100.1. They should not have it. 99 network.
This one you see there, 100.0 slash 27 below
Oh yeah,
RS. Yeah, this one.
this is the one. Okay. So this is a trusted network. So anything coming in, it has to go through the external pair of load balancers or the northeast firewalls, which is like the internet-facing firewalls.
Yeah, so it will come on this firewall and it will go to through the trusted interface of the firewall back to that blue. This blue one. Okay, sorry. Carry on, carry on.
Yeah.
So
No.
you have two load balancers, huh?
Yeah, Naval, this is all the internet-facing traffic. This is where the WAF is coming into play. And from WAF, we are decrypting the data. We are decrypting the application, doing SSL offload, sending clear text or HTTP traffic through the Palo firewalls for layer 3, layer 4 inspection, and then passing on to the LTM for the load balancing functionality. If it is like a PaaS services, then it just takes a Microsoft Internet Services. If not, then it just comes back to IaaS, which is like local, some sort of a VNet peering or in the prod environment in Azure. You got
Okay.
me?
Yeah, now it makes sense. So that's why you're pointing to 100.1, which is on the LTM on the right side. Uh, and
Right,
then, yeah, and then it goes out to, I think, PaaS service on Azure.
right.
Yeah, okay. Makes sense. And all the other traffic that comes to the firewalls, which has to go to the internet, the other direction from right to left, that takes the default route.
Right. And this is like, this is all the internet facing. So any traffic, if the application is internet facing, then it will take this route. But if the application is internal, that is like if it is coming from, if the users are sitting in the corporate office or somewhere, they just come through the MPLS cloud, Verizon MPLS cloud, take the express route. So this is like a 10 gig connection, 10 gig MPLS connection. And they come this via as an internal network. So they just point to this east-west firewall, And from the east-west firewall, they just go to wherever they are allowed to, if it is like a prod dev UAT.
Yeah, so the firewall that we were logged in, that was not east-west. That was, I think, the trust subnet firewall. Huh?
Yeah, but I'm logged into 100.64. Let me see which one I'm logged. Yeah, it is 96. So we are logging into the internet facing.
Yeah.
So 100.1 is indeed the default gateway or pointing to the load balancer, I think.
Yeah, all right.
Yep, 100.1. So this is the gateway for or the virtual IP, I can say. For
Yeah,
these
virtual
clusters,
IP.
it has to have virtual IP, and that is again pointing to this one based on the NAT.
Yeah, I got it. So that load balancer is doing load balancing across these cluster of 4 firewalls.
Right. Yep.
Okay, makes sense. Yeah.
So anything which is like trusted, I'm just saying it, all the 10 dot network, the next stop will be untrusted and pass it. But if it is all expected network, which is all 10.246, it has to go through the load balancer or the default gateway, and from the default gateway, it will be pointed to the LTM, right?
Yeah. So for all those 10 subnets, it will send to the LTM, and then LTM will send it to the app one
Wherever
pass.
it needs to.
Yeah.
Okay.
Yeah.
Okay. Yeah, this is main thing, Naval. Right now, even firewall policies and everything are being allowed. So the main thing, the main task would be enforcing the policies, like applying the rules and everything.
Yeah, true. So based on these routes, basically, you would have applied the policies across the zones.
Right. So everything has been allowed. As of now, everything is allowed. So the main criteria is to take over this and start enforcing the policies to make sure that, okay, if is it trusted, and if it is like literally, if you're seeing any is allowed everywhere. So based on the application, based on each and every firewall rule, we have to start applying the policy saying that